Hello guys, I'm your teacher Olimbokan Sijuka Masame. As we proceed with our sessions of relativity between two objects that are moving in opposite directions. You see, another case is when the man is moving relative to the bus. For this case, as usual, we must have two sets of frame of reference. The first frame of reference for the stationary observer, who records the absolute velocity for walking man and for a moving bus. As we decide to take the walking man is moving toward left, now the velocity of walking man is projected to vector OB, and as from previous sessions, the moving bus is always towards the right, and it is vector OA. Okay, and our velocity of man relative to bus will be velocity O dash to C. Okay. We put the set of axes for moving observer as a directly from the point A to this fixed positions O dash, that is vertical at the same positions, in order for this observer in moving bus, a driver will record the velocity of this walking man. And because the walking man is walking towards the left, the driver will see that the walking man is moving very, very far away from him as towards the left from his set of axis, from his frame of reference. Okay, now we will have three projected vector. The first vector is OB, and we have other vector here and the other vector here. According to the vector addition rules, we must add two vectors in order to get the resultant one. For a vector, for the rules that guides to do a vector diagrams, the first vector must be in such a way that the second vector must be drawn from the head of that first vector, and the last vector must be drawn. The last vector or resultant vector must be drawn from the tails of the first vector to the head of the last vector. Okay, let us see the arrangement here. The first vector will be here. In order to get the second vector on the head of the first vector. Here we want to get the second vector on this vector B now, but for vector A we will have according to the situations, we will have the second vector on its head, which is vector O dash to C. Then the resultant vector, as usual, we will draw from vector OA, the tail of vector OA, to the head of vector O dash C, which is vector OB now. Hence, here we'll apply our vector addition rules, because we have first vector, we have second vector, then we have resultant vector. We add two vector in order to get the resultant vector. We add VBG, as you can see, the first vector. We add plus VMB, as you can see, the second vector, which is equal to a resultant vector, which is vector VMG. Now this we make the subject vector MB, because it's the one that's required. Then the vector MB, the vector of man relative to bus, is always negative. How this will be always negative? We justify this by using the displacement. For this resultant displacement, we take the final positions, we minus with initial positions, then we divide it by time. Then the initial position from our set of vectors here, projections of vectors here from the set of axes, our initial position is OA, and our final position is OB. That's why OB we minus with OA. But remember, OB is negative because it's projected towards the left. Hence displacement S OB has got a negative sign, while OB is always projected to the right of the set of stationary observer axis here. It is always positive. And then when we divide it with time, the time that you spent by this observer, the driver who records the motion of the walking man inside the bus, this time is the one that is spent by this moving observer from OA or between O dash to C. and then the velocity here, which is velocity of man relative to bus, is always negative. Thanks for watching. Please like, share, comment, subscribe for more of videos for the next sessions, which will be the velocity of the flowing river relative to the swimmer or the boat. Okay, thank you.